you had this guy, and you spin, right? You were spinning around, right? And what happens when you stop? You still feel like you're spinning, right? It's because the fluid is still spinning. It takes it a minute to stop, right? If I'm spinning something and I stop, do you see? Well, you can't see. Sorry. If you were to like spin this,
I think we get the point.
And then you stop, the fluid's still spinning, right? Your water's still spinning until that water or that fluid. It's not water in here. Until that fluid stops, you still think you're spinning. So this gives you a sense of balance. It gives you a sense of balance. The canals are located at perfect right angles, responsible for orientation and movement of only the head. So this only is responsible for heads, what your head is doing. Yeah? We have joint receptors in our necks. Most proprioceptors, if we took the whole entire body, let's say there's 100%, right, in the entire body, about 60% of your total receptors are located in your neck. And why do you think that is? Why do we think we have most of our sensory information coming from our neck? It's telling us what our head's doing. What's in our head? Our brain is pretty important, right? So, it's important in maintaining your head to neck to trunk alignment, right? It's telling you where your head is in relationship to the rest of you. So what do you think that means in regards to balance? If your head is falling forward and it's telling you this is out of alignment, you know you're falling. Like if you were to close your eyes and you did this, you would know you're falling without needing to see it. So it's telling you where your head is to where your trunk is to where your body is. And that's really important in maintaining alignment and staying upright and balanced. Deep neck muscles have the highest density of spindles compared to all other muscles. So we have more muscle spindles in the deep muscles of our neck than any other muscles. They're highly concentrated, those muscle spindles. So we can get a lot of little fine motor skill out of you can do a lot of things with your head and neck, right? And bending forward, they try to override the labyrinth system. So what that means is, let's say you want to look down, right? So your labyrinth system is saying, your head is down, you are out of balance, you need to pick your head back up. But let's say you don't want to do that. You want to look down. These guys override the labyrinth system. So they'll shut it off and tell your brain, no, she can keep her head down. We're fine. We're in balance, right? So they'll override, because the labyrinth system is going to want to pick you back up. So anytime your head falls in space in some direction, it wants you to, you know, when you're falling asleep, what do? Right? Mm-hmm. Every time. That's a reflex. Your labyrinth system, as your head starts to fall forward, you're right, it tells you to pick it back up. But there are times when you want to look down. The labyrinth system wants you to do that and pick it back up. Neck proprioceptors say, no, don't do that reflex. Don't do that. Keep your head down if you wanted to. Any questions about that? We okay? So let's talk about a reflex. So this is a typical reflex movement. A specific pattern of responses without volition. So what does volition mean?
Signal? Communication?
Voluntary.
Oh, voluntary.
Volition is voluntary. So this is a reflex that's reflexes are involuntary, right? So without volition. An involuntary response. So, for a reflex to occur, there has to be a receptor organ. What were some of these receptor organs that we talked about? Ramble them off. Receptor organs. What are receptor organs? Muscle spindles, Pacinian corpuscles, Ruffini endings, all those organs that we were talking about, those are all receptor organs. So you have to have a receptor organ. There has to be a sensory neuron then. There's a receptor neuron. It sends, this is some stimulus that receptor organ is picking up. It picks up something. It sends it to a sensory neuron. Sensory neuron then activates a motor neuron in some way to either contract or stop contracting, and the muscle does whatever the motor neuron is telling it to do. So, receptor, sensory, motor neuron, muscle. That's the pathway of a reflex. Sometimes there's a connector neuron depending on the distance between the sensory and the motor neuron at the spinal cord level. So all of this reflexes occur at the spinal cord level. So that's a way to check to see if you have any spinal cord injury, is they'll do certain reflexes, and if that reflex doesn't occur, they know there's some damage to the spinal cord. All right. Let's talk about a monosynaptic reflex versus a polysynaptic. The only difference between these two is monosynaptic means there's no connector neuron. Polysynaptic means there's connector neurons. One or a million. Well, there won't be a million. Polysynaptic just means there's an interneuron or interneurons. Stimulus, the receptor picks that up. Sensory information goes into the spinal cord through the anterior root, right? Goes out through the posterior root. Goes out through the anterior root. Some efferent neuron. Efferent means motor. To some target muscle cell. Response. Polysynaptic just means there's an interneuron between sensory and motor. So these are the reflexes that we're going to talk about in this class. There's many, many more. There's tons and tons of reflexes, especially in babies. But these are the ones we're going to talk about. We're going to talk about how muscle spindles, these are stretch reflexes, right? Because muscle spindles pick up changes of length. The different ones we can talk about is the knee jerk reflex. There's a phasic stretch reflex, and there's a tonic stretch reflex. There's a GTO reflex, Golgi tendon organ reflex. We have neck proprioception, which are associated with tonic neck reflexes, and labyrinth writing reflex. These are the ones we're going to talk about. Yeah? Let's talk about first a static or myotonic reflex. This is a muscle spindle reflex. So, what this picture is depicting, you have a hand, right? Somebody drops a load into this hand, a whole bunch of weights goes into this hand. What happens to your arm? It goes down, right? So when this weight goes down, what happens to the muscle? It lengthens, right? Muscle spindles are lengthening. They detect this change of length. They send information up into the spinal cord, a motor neuron back down to these, and what happens? You contract. So that's a reflex. When you do, if somebody were to drop a weight into you and you go like this, that's a reflex. That's a muscle spindle stretch reflex. Let's look at this in regards to the knee jerk reflex.